All right, we got Trig lecture 9, 14, and 15 here. The student will use trig function definitions to find the length of an indicated side of a right triangle. That's what we're going to try to do right now. I'll run through these and hopefully the technique will become evident and it'll make a lot of sense. That's what I'm hoping for. So here we go. Find the length of the indicated side round to the nearest tenth. That's what we're going to try to do. And we're given this triangle here, A, B, C. C is the hypotenuse in this case. But the indicated side is called side X. It could be any variable. We could have called it a small case c. But this is the side we're looking for, the one that's a variable, the one that they're indicating to us. So what I'm going to do is I'm going to look at this and I'm going to try to determine which trig function I could use from a perspective of 30 degrees that would involve a side that I do know and the side that I don't know, which in this case is the hypotenuse. So since this is 30 degrees, from this perspective, I'd say, well, the sine function involves opposite over hypotenuse. If I want cosine, if I said the cosine of 30 degrees, that would be adjacent, which I don't know the length of, over hypotenuse, and that would give me two unknowns, and I don't want that. I just want one unknown. So I'm going to try the sine of 30 degrees is equal to 14 over x and see what that looks like. That's opposite over hypotenuse. Now we have our variable in the denominator. I'm going to run through a little bit of algebra to show you how we deal with that, and then I'm going to show you a shortcut that you can use in the future. And the reason I'm showing you the algebra first is to back up why we're able to do the shortcut. What I would do if I had my denominator my variable in the denominator is multiply both sides by the variable. What will happen there is these will cancel one another. You can think of this as x over 1. You don't have to write it that way, but you can think of it like this. And if you did, you could easily see that these will cancel. And I'm left with x sine 30 on this side of the equation is equal to 14. So I multiplied both sides by the denominator. That canceled out the denominator. The denominator disappeared and it showed up over here. Now I divide both sides by the sine of 30. Whoops. This cancels, it gives me x equals 14 over sine 30. And then I would use my calculator to round that to the nearest tenth, which would be sine 30. Be 7. That's an exact value. I said it approximately, but in this case, we didn't have to round it. It's exactly 7. Right. So it's not that much algebra to do, but there's a quick way to do it. It's a shortcut, and look what happened here. In this original equation, we had this before we did any algebra, and when we got done, the x and the sine 30 were just switched. The x was out here and the sine 30 wound up underneath because of this algebra that we did. Okay? Oops, I don't need that. So what we can do, instead of going through all this algebra, we can recognize that in a trig function like this, where we just have sine 30 or some trig function equal to a ratio that has the variable in the denominator, you can just switch these two. And what we just did algebraically is y. So you could go like this if you wanted to. Sine of 30 equals 14 over x. X equals 14 over sine 30. Switch those two. Go. And then perform this with your calculator. And if I haven't made a mistake, x in this case would be 7 units long. If it was centimeters, it would be 7 centimeters. If it was miles, it would be 7 miles, so forth and so on. So we found the length of the indicated side. We would round to the nearest tenth, but this turned out to be an exact value. So I don't have to round. Okay? Let's take a look at another one. The instructions are the same. Find the length of the indicated side, round to the nearest tenth. So I will determine the indicated side right here. This is the side I want, and I want to round it to the nearest tenth. So I'm going to say, well, if I said the sine of 41 degrees, now this is the wrong thing to do. And I just want to illustrate why you wouldn't do that. That would be opposite over hypotenuse. That would give me a value that I'm not looking for. I'm looking for this side right here. This is the indicated side. So I want to find a trig function that involves this angle, the adjacent side, and the hypotenuse. So that would be cosine, not sine, not tangent, but cosine. From this perspective, the angle that we're given, we could say that the cosine of 41 degrees is equal to adjacent over hypotenuse. Now, in this case, our variable is in the top of the fraction, so we don't have to do any fancy algebra. We just ask ourselves, well, this is x divided by 5. How do I get rid of a divided by 5? I multiply by 5. So I multiply both sides by 5. Rewrite my equation, 5 cosine 41 degrees is equal to x, because these cancel. And then I evaluate this with my calculator and round it to the nearest tenth, because we were asked to do that. I got 3.8 approximately. And if it had units on here, like millimeters or centimeters or miles or light years or whatever the unit of measure is, we would indicate that. But since it's not giving us an indicated unit of measure, we don't have to write it. So x is 3.8, and you can put the x first if you wanted to. That's just fine and dandy. Okay, so we found the angle that we know, and the two sides that we knew turned out to be adjacent and hypotenuse, so we used the cosine function. Alrighty? Let's take a look at this one real quick. Here's the angle that we know. Here's the side that we're looking for, and the side that we also know. So I want to, again, I'm going to involve the adjacent side and the hypotenuse. So I'm going to use cosine again. It's just a coincidence. So I'm going to say that the cosine of 19.3 degrees is equal to x over 16, adjacent over hypotenuse. Once again, I have my unknown, my variable, in the top of the fraction, so all I have to do is multiply both sides by 16. We undo a divided by 16 by multiplying by 16. This will give us 16 cosine 19.3 degrees is equal to x, and then we perform that operation with our calculator. And I get about 15.1 units. I'm going to change that to an approximation symbol. Since I've already written an equation symbol, I can just put a single little dot above it, and that tells my reader that this is an approximation. Okay, there are two ways to write approximation, or approximately. There's the squiggly equal sign, or a regular equal sign with a dot on it. Both of these mean approximately. So there we go, x is approximately 15.1 units. Again, we weren't given the unit of measure, so we don't have to indicate the unit of measure. If we were given the unit of measure, we would want to indicate it in our answer. And the last one, let's see what we got here. We're looking, we have this known angle. This side is what we're looking for, and this side is what we're given. So from this perspective, from the perspective of this 27-degree angle, that would be opposite over adjacent. Here's the hypotenuse, and we don't know the length of it, but we're not asked for it. We're asked for this one. This is the indicated side. So I'm going to say the tangent of 27 degrees is 3 over x. I'm going to do that little algebraic thing that we did in the very first problem. Since the variable's in the bottom of the fraction, I can just switch these two by that little bit of algebra that we did before. X equals 3 divided by the tangent of 27. And then I'll perform that operation with my calculator and round it to the nearest tenth, because that's what I'm asked to do. It looks like it's about 5.9 units. That would be light years or miles or yards or micrometers, but whatever our unit of measure happens to be. In this case, again, we don't have an indicated unit of measure, so we don't have to show it in our answer. If we did have an indicated unit of measure, for instance, if this was 3 miles, we'd want to say this is 5.9 miles. That's how long this would be. Okay? And I believe that's it. So now hopefully we know that we can use trig function definitions to find the length of an indicated side of a right triangle as long as we know one of the angles. And of course, if you know one angle, you automatically know the other one, because the acute angles in a right triangle are complementary. They'll add up to 90 degrees. So if this is 30, this one is 60. And you could use that angle for your trig function if you wanted to. If this is 41, this one is what would that be, 49? So forth and so on. These have got to add up to 90. All right, so there we are. I hope that made sense.